Hello everyone, I am Srinidhi from Data Science Department. I am pursuing my engineering at Sri Venkateswara College of Engineering, Bangalore. Today we are going to see about the topic theory of computation. Like in theory of computation, the topic here is the pumping lemma program. Introduction to pumping lemma. The pumping lemma is a fundamental concept in the theory of formal languages. It provides a technique to provide that certain languages are not regular. Understanding this lemma is crucial for studying automata and computation theory. Let us see about the definition of regular languages. Regular languages are those that can be expressed using regular expressions. They can be recognized by finite automata, either deterministic or non-deterministic. Example of regular languages include simple patterns like A. Now let us see about the statement of the pumping lemma. The pumping lemma states that for every regular in languages there exists a pumping length. Any string longer than this length can be divided into three parts. The middle part can be pumped, repeated to create a new string that still belongs to the language. Components of the pumping lemma. The lemma identifies three parts of the string, that is x, y and z. The condition requires that mod of xy is less than or greater equal to p, where p is the pumping length. The string remains in the language when y is repeated any number of times. Application of the pumping lemma. To use the pumping lemma, one must assume the language is regular and derive a contradiction. Choose a string in the language that meets the condition of the lemma. Shows that no matter how you pump the new string do not belong to the language. Let us consider an example of a language. Consider the language L, that is equals to a to the power n, b to the power n, where n is greater than or equal to 0, which consists of equal numbers of a's and b's. This language is not regular and we can prove this using the pumping lemma. Any attempt to pump the string will disrupt the balance between a's and b's. Steps to prove non-regularity. Like starting with the string s from the language that is no longer that is longer than the pumping length. Decompose into x, y and z according to the lemma's constants. Like demonstrate that all possible pumped strings violate the language's definition. Now let us see about the limitations of the pumping lemma. The pumping lemma only applies to regular languages and cannot be used for context-free languages. Not all regular languages can be proven non-regular using this lemma. Alternate methods such as closure properties can sometimes be more effective. Now let us see about importance in computation theory. The pumping lemma serves as a tool for understanding the limitations of the regular languages. It helps in the classification of languages and understanding their properties. This concept is foundation for further studies in automata theory and formal languages. Conclusion. The pumping lemma is essential for proving non-regularity in form languages. By mastering this lemma, one gains insight into the capabilities and limitations of finite automata. It lays the groundwork for exploring more languages classes in computer science. Thanks for watching. Please like, share and subscribe my channel.